Hi guys, this is Sheriffdeen Academy. Welcome back to this YouTube channel. In this video, I'm going to be talking about the minimum and the maximum reinforcement area for slab, beam, and column. If this is your first time on this channel, you know all we do here is to create content on civil engineering design and construction. This is important for us to understand the terms called under reinforcement and over reinforcement. So we are going to be driving everything we have to say from the Eurocode, which is the EN 1992 part 1 of 1. We discussed about the general rules for buildings, that is the design of concrete structures. So let's talk about the minimum and maximum reinforcement area for slab and for beam. So you can actually find this in clause 9.2.1.1 of the code. So for example, let's say we have a typical beam. This is a typical beam in which the length of the beam is given as L, the width of the beam is B by standard, and the height of the beam is H. The minimum area of reinforcement that will lead to the minimum spacing of the slab or the beam is given by a single formula in the code. We have the AS minimum equals to 0.26 FCTM BTD over FYK. FYK is actually the design strength of your reinforcement, which ranges from 400 to 600 Newton per meter square. The D is the effective depth of the slab or the beam. This can actually be obtained after you've removed the cover to the reinforcement and then the links in case of beam. Then the BT is the width of the beam. But when you are talking about the slab, you can take your BT to be 1 meter because the slab is designed per meter run. So that means the width of the slab is assumed to be 1 meter. The FCTM depends on the concrete strength. This can actually be found in table 3.1 of the code. So from this table, we can determine the FCTM. This is the FCTM. Then depend on the strength classes of concrete. If you are using a concrete strength of 20, then your FCTM is going to be 2.2. You should know that the Eurocode is actually based on the cylindrical strength of concrete, not the cubic strength. So what you are having here, which is the FCK, that is the design strength, is actually the cylindrical strength. So if the cylindrical strength based on your design is 20 Newton per millimeter square or megapascal, then your FCTM is going to be 2.2. So you can easily read your design strength against the FCTM from this table. This table is found in table 3.1 of BS EN 1992, the Eurocode part 2. As for the maximum reinforcement for slab and beam is given by this formula is just 4% of the area of concrete, that is 0.04 multiplied by the area of concrete. In case of slab, you are going to take your B to be 1 meter, while in case of beam, the B is going to be the width of the beam. So slotting this slotting your variables inside all this formula is going to give you the required area of reinforcement both for the maximum and for the minimum. So whenever you are providing something above the maximum, you know you are over reinforcing the section. Then when you are providing something below the minimum or below the design reinforcement, then you should know that you are under reinforcing the section. From the minimum and the maximum area of reinforcement, you can now deduct what we call the minimum spacing and also the maximum spacing. So let's give a typical slab. This is a typical arrangement of slab reinforcement. The spacing between the reinforcement is what we call spacing. The distance between the reinforcement is what we call the spacing. And then this spacing has a guided rules. It has to follow a particular rules that guide the minimum and the maximum, in which you can put two reinforcements. You can separate two reinforcements from each other. So for the minimum spacing must always be greater than the bar diameter. This depends on the bar size of the slab or of the beam. So if the bar size of the beam is 12 mm, so that means the spacing between those two reinforcements must be greater than 12 mm. Then we talk about the aggregate size plus 5 millimeters. The 5 millimeters is for tolerance. So depending on the kind of aggregate you are using, if your aggregate is 20 mm or 19 mm, then your spacing must be greater than that size plus 5 millimeters. Then we also have 20 millimeters. So that means theoretically the minimum spacing you can provide in a reinforcement should be like 30 millimeters or 25 millimeters. Then we talk about the maximum spacing of reinforcement. So the maximum spacing of reinforcement for slab and beam is taken as 400 millimeters or 4H. This actually applies to distribution reinforcement, but in case of main reinforcement, where we have the maximum amount of bending moment along the slab or the beam, then the spacing should be taken as 250 millimeters or twice the size of the slab or twice the size of the beam, whichever is lesser between the two. So from here we can now estimate that we can determine the minimum and the maximum spacing for slab. So let's move to the column. For the column, you can actually find this in clause 9.6.2 of the column, where the minimum and the maximum reinforcement for column is discussed. This is a typical column in which the base is said to be casted. So for columns, we have the main reinforcement. The main reinforcement are the vertical reinforcement. Then you also have the links. The links holds the main reinforcement together. So a typical sizing of a column is L is the length, B is the width of the column, then H is also the height of the column. The AS minimum for column is given by this formula. AS min equals to design easier load divided by the design strength of steel. So this can actually range from 400 to 600 Newton per millimeter square or megapascal. So this value that you obtain here must always be greater than 0.002 multiplied by the area of concrete. So the value here that you obtain from this formula must be greater than 0.2% of the area of concrete. So whichever is higher between them is going to be the minimum value for the minimum area of reinforcement for the column. In case of the maximum is 4%. That is the 4% multiplied by the area of concrete. But in case where we have lapping and joint, then in that case you can have 8%. This is actually being specified in the code as well. You can do well to hit the subscribe button, turn on the notification. So let's talk about the minimum spacing for links in column. Spacing of links in column is the distance between the vertical reinforcement, that is the distance between the shear links that are used to hold the vertical reinforcement together. The size of this shear link must always be greater than 6 millimeters. That is, you cannot use a reinforcement that has a diameter less than 6 as your links based on the Eurocode. Then the spacing between these links must always be less than 12 times the bar size diameter. So let's say you are using a diameter of 12 mm, then the spacing you must use between these links must be less than the value of 12 times the size diameter. So for 16 mm now, the spacing must always be less than 200. Must not be more than 200. Then the spacing should also be lesser than the dimension of the column or the beams. So let's say your column is 200 by 230 by 230, then the spacing you are going to use between your shear links must always be less than the size of the column. Then the spacing must also be less than 240 millimeters. So these are what I just want to summarize for you in this video. Then from this you can understand if your slab beam column is either over reinforced or under reinforced. Thank you. We are going to meet in the next one. See you next time.